Okay, so I think everyone signed in already, but in case you didn't, we'll say it again. So today's workshop is going to be about setting up a web server with DigitalOcean and Nginx. DigitalOcean is a cloud platform or a cloud provider that has a bunch of services, and I'll explain what Nginx is. So the agenda for today is pretty straightforward. First off, what is a VM or virtual machine, and what is a VPS? Stands for virtual private server. Then I'm going to talk about like a little bit of what Nginx is conceptually, without getting too into the weeds of it. And then the rest of the workshop will just be a follow along coding demo. So if you have the GitHub Student Developer Pack, that'll give you $200 worth of credits to use for DigitalOcean. But if you don't, it's only going to cost $4 or $6 depending on like the availability of the thing we use. So it's not too expensive anyways. So what is a virtual machine? So as hopefully you know, or if not, it's fine. A computer is a physical machine that's made up of different parts like, the CPU, the memory, the operating system. A virtual machine takes these parts and says, what if we could get the benefit of the computer and like all the benefit that these resources bring without having to maintain a physical computer, without needing the power to, keep the computer running, without needing the space to have the computer, and without worrying about the hardware breaking. So virtual machine is nothing but software that simulates a real computer down to the hardware level. So it's actually just a piece of code. There is source code on GitHub for different virtual machines if you wanted to check it out. But how can you actually use a virtual machine? Before getting into what it's good for, how can we create one? There's two main ways that you can create a virtual machine. You can create it locally on your own computer, run an instance of a virtual machine using technology like VirtualBox or VMware, or you can run it in the cloud through a platform like DigitalOcean, which is what we're going to be doing today in the demo. So before I talk about the benefits, I just want to, I guess, recap that. When you create a VM, it's almost like you're creating a computer inside of a computer. So what are the benefits? There's a few, and the ones I listed, it's not a comprehensive list or anything. It's just the ones that I think are most relevant, and I guess the simplest and easiest to understand. So the first is actually the least obvious, is that it can abstract the operating system away from hardware. So on a real computer, the hardware and the operating system are really closely linked in that if the hardware were to break, like any piece of hardware were to break, it could cause your operating system to break and your computer kind of stops working. So what a virtual machine does is it separates the hardware from the operating system so that it's no longer dependent on the physical stuff because everything is being simulated virtually. The next benefit is it lets you have a safety net. And what I mean by that is, I'll give an example. Let's say you see a program on the internet, and this program is called notavirus.exe. And since you're such a genius, you want to download notavirus.exe and try running it and seeing what happens. What a virtual machine does is it allows you to download potentially risky software and actually run it without putting your actual machine at risk. And this is because a VM is partitioned or separated down to the operating system from your host machine. So if you were to break your VM or, I don't know, do something irreparable to it, you can just destroy it and rest assured that your actual computer is totally fine. Another cool thing or benefit is that it lets you learn and experiment with different operating systems. So I have a Windows laptop. So let's say you also have a Windows laptop, but you want to learn how to work with Linux or Mac OS, but you don't want to shell out, 1,600, however much money for a new computer. You can just spin up a VM, run an operating system of your choice, and then learn and experiment with as if you were actually using a computer running that operating system. And then the last benefit that I put here is that you can test applications on different operating systems. And for this one, I'll give another example. Let's say you're a TA for Programming Fundamentals 2, and you have a Windows laptop, and a student comes to you with an issue with Minesweeper. They're trying to do Minesweeper final project, and they're having a hard time setting up SFML, but they're running a Mac operating system. And let's say that the bug is to the point where you have to actually get in and work, through the command line to see what it is. It's not a coding bug. So you could try to actually do everything, try to debug on the student's machine, which is definitely a lot more convenient. But let's say you're like scared to break their machine, or you want to like really have freedom to experiment with different commands. You can just spin up a VM on your computer running Mac OS, if they're running Mac OS, follow whatever setup steps they had to reproduce their bug. And then from there, you have all the freedom in the world to debug and mess around and try and fix the error without worrying that you will either break the machine and also being able to work on a machine that's very similar to theirs. Then at the bottom, these links are just, I think, helpful resources to understanding what a virtual machine is. Definitely not comprehensive either, but I think they do a good job at making it simple and easy to understand. So that's a VM. A VPS, which stands for Virtual Private Server, is really similar in that it's actually the same technology. It's just kind of a different name for a VM. But the way that I think is helpful to think of it is that if a virtual machine is the technology, then a virtual private server is the product. So you can rent a VPS from a cloud provider like DigitalOcean. So the droplets that we're going to create today is just DigitalOcean's name for a VPS. Okay, so what is Nginx? Well, Nginx is actually a really diverse technology in that it has multiple applications. But for the sake of today's demo, we're going to be using it as a web server. So to answer this question, it's really what is a web server? A web server is just a computer program that stores and delivers files like HTML files, and then serves them to a client when they request it through a web browser. So in this diagram, you have your user, which would be like, I don't know, you or I don't know, me, using Google Chrome and looking up a website. When we look up the website, Nginx acts as a middleman between the actual like source files, and it uses HTTP or hypertext transfer protocol to get these files and then serve them or draw them out to your computer screen. And that's about as deep as I'm going to go conceptually and like technically in what Nginx is, because there's definitely a lot to read. But I think having a conceptual understanding is more helpful right now. So yeah, that's all there is for the slides. The rest of the workshop is going to be a demo where we're going to be creating a website that we can actually access on the internet using a VM and an Nginx as our web server. So I'm going to switch the screen that I'm sharing. Okay. Is it? I'm not sure if it's sharing on the Zoom. Are you able to see it?
Yeah.
Okay.
Wait, what am I supposed to see?
I'm just sharing. It should just be like a Zoom page. I'm sharing my screen.
Yes, yes.
Okay. So this is nothing. So to get started, if you followed along with the, I guess, instructions beforehand and set up a DigitalOcean But let me change the screen that's being presented as well. There you go.
On the tablet. So the same place.
Okay. Anyways, so the first step is just to go to DigitalOcean. And log in. So I was already logged in, but it should prompt you to like sign in with GitHub if you set it up. So yeah, obviously since you connected your GitHub account to the developer pack, you can sign in that way. And from here, we're going to create a brand new project through this left sidebar. This left sidebar has a lot of these services offered by DigitalOcean, but we're just going to create a new project for now. You can name it anything you want. So I'm going to name it demo project. Description, I'm going to leave blank, and then educational purposes, and then just hit create project. And you can skip this step for now. And you should be taken to a console that looks like this. And from here, you can manage the different resources of your project. You can check the activity, which we don't have any since we just created it. And then you can check the settings and destroy the project if you wanted to from here. So we're going to spin up a droplet, which is just DigitalOcean's name for a virtual machine. So to do that, you go to the top right and press create, and then just select droplets. And from here, you're taken to a menu where you select different options to actually do the setup. So the first thing is choosing our region where we want to host this. And right now, all we're doing is just kind of renting out DigitalOcean servers to run our virtual machine on their hardware. So I'm going to pick whichever region is closest to you. I'm picking New York. And then for data center, you can just leave this as is. So the first real choice is when we're choosing an image. So here we're going to be choosing the operating system of our virtual machine. So I'm going to say about I don't know, 80, 90, maybe even more % of servers are Linux based. So if you want to get into servers and working with them, you should definitely learn Linux. As you can see, we have different Linux distros here. We have Ubuntu, Fedora, Debian, CentOS, Alma Linux, and Rocky Linux. I'm going to choose Ubuntu. And before I pick the version, I also want to mention something neat that if you know what your tech stack is that you're going to be working with, for example, let's say I'm building a project that I know is going to need the MERN stack. You can choose custom images that are already created and set up for you so that all the packages and stuff that you need is set up and you don't have to actually do anything. So for example, if I wanted to make a MERN project, I go down here and Zoom is blocking the bottom, but it tells you what comes pre-installed. We're going to do everything from scratch. So I'm going to go back to OS, press Ubuntu, and change the version to the long-term support, just because that's the most stable and it has long-term support. Then the next choice that we have to make.
What type of project did you select in the first page?
The project from here.
It's giving you options: deploy web application, host a website, deploy container-based app, deploy database, deploy virtual machine, store static objects.
Oh, it'll probably be deploy virtual machine. I mean, all I did was just create a project and name it something. And when I clicked through, it just took me to this thing. On the left-hand side, do you see this? Just click into your project and then press create. And then it's droplets. So from here, region, Ubuntu, long-term support. Now we're going to choose the size. So these are the different, I guess you can choose a shared CPU, which is what we're going to be choosing for today because we're building a really simple static website. But you can choose a CPU that is either storage optimized if you want to host an entire database on your virtual machine. You can optimize it for memory, for CPU. If you're into AI or machine learning, I believe they have GPU optimized plans as well. I haven't looked into that. And then there's also general purpose, but we're gonna go with basic because it's cheap, it's basic, it's all we need. And then for CPU options, again, we're gonna go with the simplest option because we're not doing anything crazy. And again, we're just gonna press the cheapest option. So you will be billed, but this is why hopefully this is what the point of the GitHub Student Developer Pack is. With that, you're given $200 worth of credits, which goes a long way. So if not, it's just $4. And I think it's worth it just for learning. Anyways, so we're gonna pick the cheapest one because we're building something pretty small today. And then additional storage, we can skip this. Backups, you can enable it if you want, but it'll charge you. I'm gonna skip that as well. And then the next, I guess, important choice is the authentication method for connecting to your droplet. So there's two options. There's connecting via SSH, which is generally more recommended and more secure, but also a little harder to set up. It's not very hard, it just takes a little bit longer. Then the other option is to connect by password. For today, since I'm focusing on just the server setup, I'm gonna connect by password. But if you wanted to connect via SSH, you would just press new SSH key and then follow the instructions here and do some Googling if you're confused. But I'm gonna connect by password. So when you're creating your root password, make sure to write this down because like it says there, it's not gonna email you. So if you don't write it down and you forget, there might be a way to get it back. I'm not sure, but you should just write it down. I'm gonna make my password something really simple. So, you know, I'll just type it out here and paste it. And it's fine. I'm gonna destroy this droplet right after, so it's fine that you're seeing this. Okay. And then you can add monitoring stuff for free if you want. I'm gonna skip that. And then I'm skipping this managed database as well. I'm just making a very bare bones VM. And then for the host name, you can leave it as the default, but I'm gonna change it to something that is not just garbage. So I'm just gonna call it demo droplet. You know, I'll call it my demo droplet. Tags you can leave blank, and then project. If this is your first time setting it up, you should only have one project. I'm gonna assign it to demo project, the one that we just made. And then you press create droplet and give it a minute, and that's it. It's pretty simple to set up. Hopefully it should be quick. The Wi-Fi is good, I'm not sure. Okay, so once you get to here, we're gonna do the rest of the managing of this server through the terminal. So I'm gonna open up terminal. And the process should be pretty much the same for Windows, Linux, and I think Mac OS. I haven't done it on Mac, but it should be the same. And we're just going to SSH, which stands for Secure Shell Connection, into our root user and then we want to connect to our droplet that we just created. So we need to get the IP address of the droplet and paste it in. So right now what we're doing is from our local machine, we're going to be taking control of the droplet almost like remotely, like we're hopping into a remote piloting seat. And then you just hit enter and you can type yes to this message and it'll add it to your known host so that way you can connect and you won't see this message in the future. And then the password that we just created that hopefully you wrote down, you're going to type it here. And it won't show up just, you know, for security reasons, but it is typing. So just hit enter. And you can see we're connected to our droplet now. So we're the root user, or in other words, the user with the highest level permission. And then we're working inside my demo droplet because that's the name that I gave it. Okay, so I mean, if you got this far, if you're following along, good job. You set up your first VM. So now we need to do some more setup steps. So the first thing that we want to do is we want to update all of the packages inside our server with apt, which is the package manager for Ubuntu. Update. And then we can do, this part is optional, but I like to do it apt upgrade. Then just continue. Dang, that might take a while. It usually doesn't take this long. I think it's just because like UF Wi-Fi or something. But the reason that you want to do this is mainly for security and stability reasons. You want to make sure that all the packages on your VM are up to date to where they should be so that they're stable.
I have a question. What steps did you choose for the droplet, like the operating system, the size and everything?
For the operating system, I chose Ubuntu. And then when it says version, I picked 24.04, like the long-term service one.
Yeah.
For the, I don't remember the names, but I chose like the basic, like the shared CPU plan. The standard CPU, like the left one, pretty much everything to the left, like the cheapest version.
The $4 per month one,
Yeah, I chose the $4.
and that comes out of the $200 credits.
Yes, I would say if you're planning on like using this one, I'll talk about this screen in a second. If you're planning on using this like more than for this demo, I would at least go for the $6 one.
Okay.
But for what we're doing, I tested it with the $4 one and it works fine. So for here, you just want to make sure you're like clicked into your terminal, and then this is fine. You can just use the arrow keys to navigate to install the package maintainers version and hit enter. Should be almost done. I kind of ate up into the time more than I was hoping, so I'll try to go, I guess, like a little quicker for the rest of the stuff. Okay, sweet. So now everything should be up to date. You're working on like a clean machine. So the first real step, excuse me, is we want to actually install Nginx to our machine. So we're gonna do apt install Nginx. And if right now you're thinking that I might have skipped a step, I'm intentionally skipping a kind of important step, which I'll go over at the end, just to show, I guess, the meat and potatoes, like the important, what I think is the core of what we're trying to do. Okay, so now we have Nginx, and we can check that it is running with system control status Nginx. So if you do that, it just shows that this is the service is actually running. And I believe at this point, if we want to connect to this online, you can just go back into the console, copy the IP address, and then paste it in here. And it will say failed to connect, and I'll explain. Oh no, okay, it didn't say that. Okay. So yeah, so this is the default output. When you install Nginx for the first time, it serves this default web page. If you want to see the actual source files for that, you can press Q to sit here. I'm gonna press Control L just to clear the screen. And then we can move into the following directory /var/www/html and then ls. So we're actually serving the code that exists at this HTML file. So to show you, I can output the contents with cat, and you can see welcome to Nginx. If you see this page, blah, 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 it's all matching up here. Oops. So this is a pretty boring website. I want to do something a little cooler. So I'm actually going to use a template site from GitHub that I found for this. I think I'll send the link in the Zoom chat. If anyone wants to like clone it and follow along. So I'm going to be cloning from this Git repository. And to show you like what it is that we're actually going to be serving, I set this up already, and I'll demonstrate what it is with the live server extension on VS Code. So you don't have to follow with these steps. I'm just showing what it is that we're actually going to be replacing that default site with. So we're going to be setting up this website that I thought was kind of cool. This is just a fancy like HTML, CSS, site. But we're going to be serving that at this IP address. So to do that, we're going to go back to the terminal and we're going to do the following commands. So you're going to change directories into var www. And then you're going to clone the repository that I linked in the Zoom chat into this directory. So git clone this. And then we can see the files. These are all the files. We're going to be serving the content from this site. So to configure which site is actually being served to via Nginx, you want to go to this folder, which is etc. Nginx sites enabled. And for now, like the difference between the folders isn't super important. That's more of like a Linux thing, like how things are organized. So you can just follow along for now and read up on this later. And then from here, we want to change the configuration files. So right now, if we were to output what's currently being served, we can see we're serving the file that exists from root var HTML. That's the one that has this HTML file. But we want to change this to serve from the new Git repository that we just cloned. So to do that, we're going to use a text editor called Vim. You can use whatever, if you are familiar with like text editors like Vim or Nano, you can use whichever one you want. I like using Vim. So that's the one that I'm going to use, and it comes pre-installed with your VM. So to do that, you press Vim, or you type Vim, and then whichever file you want to edit. And so the point of a text editing thing is you can't use the mouse, so you can't actually click into things. But for now, just follow along carefully, like with the instructions, and it should be pretty simple. And if you like get stuck using Vim, just like let me know, and I'll try to help you out. So you just want to hit the escape key. Zoom is blocking stuff. Okay, all right, hit the escape key. And then you can use the arrow keys to navigate all the way down to where it says root. All the like blue stuff with the pound sign next to it is just commented out, just like a normal code. And then from here, we're gonna want to change the content that's being served from this default site to the one that we just created. So we're gonna delete this. You hit I to enter editing mode, and you should see insert at the bottom if you're in editing mode. So again, you just hit I, and then we're gonna delete HTML, and we're gonna change this to the Git repo that we just cloned. Site. Okay, then hit escape, and to save changes in Vim, you press Shift, then the semicolon to bring up the colon, and then quit. So this is just saving our changes. And hopefully that's all the Vim that we're gonna have to do for this demo. So from here, if we were to refresh our page, you'll see that nothing actually changed. It's still serving the same thing. In order to, I guess, refresh or like actually do the changes that we just made, you have to run the following command. You have to reload Nginx with system ctl reload Nginx. Okay. And then after doing that, if you're to refresh this page, you'll see that this is the site that we cloned. So now anyone can actually access the site. If you wanted to like Google this right now and like type up this IP address from your own computer, you would see the same thing here. So this is actually alive on the internet right now, but we're not done yet because I intentionally skipped a lot of these setup steps to get to the end goal faster. But right now, this is kind of a security, like it's not very secure, and we're not following best practices for working with a server. So I'm going to show what best practices are right now. So first things first is we're going to go back into our terminal. Again, I'm going to press Control L to just clear the screen. And the first thing that you want to do is create a new user with sudo privileges. So what do I mean by that? Right now, we're working as the root user. We're working with a user that has all the permissions in the world to potentially do, make catastrophic damages to our virtual machine by accident. So it's not smart. You generally don't want to work as root user ever. So the first thing that you want to do is create a new user with the command add user and then your username. I'm going to call it my user, but you can call it whatever you want. And then if you hit enter, it'll prompt you for a password. Again, write this password down because it's not going to show you it again. And there is a way to reset your password, but it's kind of a pain. So just get into the habit of writing all these passwords down somewhere you won't lose them. So I'm going to type a password. And again, it won't show you the output, but just trust that it actually is typing. And then for the following fields, you can just enter, like click through them. These don't really matter. I'm just going to skip these. Then yes. So we created a new user. If you want to, as like so far, if anyone's following along, hopefully I'll just give it a minute, like questions or anything in the Zoom maybe. Otherwise, I'll continue. So if you messed up and you wanted to delete your user for any reason, you can just do user del for user delete /r, whatever username it was. I'm not going to do that. But from there, you can just make a brand new user. And the next thing that we want to do after creating this user is giving it privileges, sudo privileges. So sudo stands for super user, which is just a longer way of saying root privileges. So it's like the highest level of permissions that you can give a user. So to do that, you do user mod to modify the user, then -AG. These flags are to append the user to a group, and we want to append the user to the sudo group, and then you do your username. And you won't see anything, but again, just trust that this works. And then from here, we're gonna do the rest of the setup from this brand new user that we created. So you can either exit here, or I'm just gonna make a new terminal window and SSH as that user into the VM. So this is gonna be very similar to what we did at the beginning. It's just SSH, then the brand new username that you just decided. So I did my user at, and then the IP address of your virtual machine. So I'm gonna go back to the console, and you can always copy this IP address here just by clicking copy and pasting it into your terminal and then hitting enter. So it'll prompt you for the password. So hopefully you wrote it down or you remember it. And then you just type it, hit enter, and you can see we've successfully SSH as my user
Could you go up a bit?
into the droplet.
Could you go up a bit?
Yeah, so this information here that all this is just a welcome message. It has some information like,
I was just checking the SSH.
oh, right, SSH, your user at your IP address.
Right.
And yeah, actually this stuff is kind of cool too, because it tells you, how many users are logged in and your memory usage and a bunch of other stuff. So now if we we set up sudo correctly, again, we can do this time sudo apt update. So I'll show you, if you do apt update now without sudo, you'll get a permission denied error because you need to have root privileges to do this. So we're gonna do sudo apt update. And then you put in the password. And it'll do the same thing. I'm not gonna upgrade this time because that took forever. But again, this is just updating your packages for like security and stability purposes. And speaking of security, the next thing that we want to do is set up a firewall. So I'm gonna talk through, I guess, how to do that with code first, and then why to do that. So first things first is we want to check if our so okay, let me back up. Linux machines come with a firewall called UFW, which stands for uncomplicated firewall. It's a front end to configure which ports can be connected to which applications are allowed to run. So to interact with it, we can check if it's running currently with sudo UFW status. And you can see it's inactive. So we want to activate it, but before we do that, we want to do some setup. So we're going to do sudo UFW default deny incoming. And that just denies any incoming connections. Then we're going to do sudo UFW default allow outgoing, and that allows outgoing connections. And then there's one more that we want to allow so we can actually SSH into our machine. We want to allow or sudo UFW allow open SSH, and that'll make it so we can keep SSHing if we like get logged out and out. So you say enter, and then to see which you can do sudo UFW status, but we haven't enabled it, so that won't do anything yet. So yeah, let's just enable it. Sudo UFW enable. And you can just hit Y. So now firewall is active and enabled on system startup. It's already enabled. You don't have to like restart the system. So now if we were to do, if we were to check the status, you can see that it's active and the allowed connections are, open SSH connections on the default port. On the default SSH port, which is 22. So a little conceptual stuff about why you want a firewall. So a computer has thousands of ports. It has, I don't remember the number, it's in the thousands, and any one of these ports is a way for somebody to enter and start interacting with your machine in some way. And that is obviously very bad, because that just means that anybody with brains can get into your computer and start doing some malicious stuff. So you want to have a firewall to prevent the connections from those people, and that'll protect you from you know like port scanning. It can reduce DDoS attacks. All these security things that I honestly don't know too much about, but if you want to learn more about like security, definitely check out UFSIT, I think that's Security Information Technology Club. But then from here, you'll notice that if we were to go back to our website and refresh this page, you'll note that it's taking a long time to actually load. And that's because we kind of broke it by enabling our firewall. So this will keep loading and eventually it'll say that it failed to connect. We kind of broke it by enabling our firewall because Nginx, the application that we like set up, is no longer allowed because we didn't explicitly allow it with UFW. So in order to fix that, you just go back into your your VM and you do the following command: sudo UFW allow, and then we want to allow Nginx HTTP. And there's actually, okay, and yeah, you can see our site's back because we allowed it, everything's back to normal. If you were to do sudo, I believe UFW app list, these are the applications that that are available to either enable or disable. So we added Nginx HTTP because we haven't actually set up HTTPS. HTTPS is just a more secure version of HTTP. And if you were to buy like a domain name like somesite.dev, you have to set up HTTPS for that on certain browsers. Otherwise, you wouldn't be able to connect like through Chrome. You wouldn't be able to connect through Arc. You wouldn't be able to connect. But we're not going to do that in this tutorial. But if you're just curious, like which apps you can actually enable, you just do sudo UFW app list, and here's all the applications. And yeah, honestly, that's it for this demo. But I do want to explain what the next steps were, or what the next steps are if you want to take this a little bit further. So there's a few things you can do. So right now we're connecting to our site through an IP address, which is really annoying because I mean, no one's going to remember that. It's impossible to find. So you're used to connecting through sites, through like, DigitalOcean.com or some domain name. So what you could do next is buy a domain name through a provider like Namecheap, or I use Forkbun, and then set up what's called an A record so that people can actually connect to your site from, excuse me, from a website name instead of typing the IP address. And from there, you can set something up called server blocks, which I'm not going to get into what that is, but that just lets you serve multiple different sites from the same droplet. So you could do that. You could also, right now we're manually editing all the HTML and like website files directly by interacting with our VM, which really isn't a good practice. So you could set up a simple CI/CD pipeline, like a continuous integration or continuous development pipeline. So that way you can do actual coding on your machine, use like VS Code or whatever IDE you want, and then automate the deployment of that code to your droplet. And that'll just make things like 100 times better. That's another thing you could do. You could also finish securing it, which I have a link that kind of briefly goes into how to finish securing your VM. You could also generate an SSL certificate so you can connect through HTTPS. And then another thing you could do, which I think is definitely important, is setting up SSH, because right now, every time we connect, we have to type in a password, and that's kind of a pain and also not the most secure way to do it. If you were to generate an SSH key, it's a lot more secure, and you won't have to retype. You'll just like connect without having to do any intermediate steps. So there's a lot of different ways that you could keep this going. If you're interested, DigitalOcean has like a 39-part tutorial series where each part is like a long article on something related to cloud computing. So they have an article on Nginx, which was when I was like setting it up for the first time, I followed a bunch of these tutorials. They have an article on SSH, all that. So yeah, so that's a demo. Hopefully that helped out. And if anyone has like any questions in the Zoom or in person, I'm definitely down to help out. I'm gonna stop the recording.